will be after the meeting, and I will come up to you with the mic so you can ask a question, okay? So enjoy the tutorial.
All right, wonderful. Well, it's great to see all of you here today. As Reen said, I'm Dan Vreeman. I am the Chief Standards Development Officer here at HL7. And it's a real pleasure to be back here at DevDays with all of you. Some of you may know me from past roles. I joined HL7 at the beginning of this year. I was with RTI International for a couple of years, leading interoperability projects there. And before that was at the Regenstrief Institute for many years, where I led the development of the LOINC terminology. So you can see that terminology is something I'm really excited about. So today, what we're going to try to do is explore two main sort of thematic areas. One is the idea of why and how we should use coded terminologies in FHIR. And then the second is to explore some of the core resources defined in the FHIR specification and the operations that go with those resources in FHIR's terminology module. So if we can do that, then I'll hit my target for the session today. But I wanted to start by letting you in on a secret, which is if you are working with health data, your life is going to be very messy. And it's going to be messy in a variety of different ways, some of which FHIR helps a great deal with, others of which are still remaining as messes. And one of those areas that's really, really messy is the idea of representing clinical concepts with shared meaning. And the trouble is that variation exists everywhere that you look for it. So if we wanted to take just as a simple example, a very, very basic clinical measurement, diastolic blood pressure, and we looked across the many institutions, say I was in Indiana for a while, so around central Indiana, and looked inside their systems, how do they represent this variable? You see different codes and different labels for that same measurement. And to a human who can review all these, you can make a judgment that this represents the same thing and is able to be aggregated or plotted together or what have you. But if you're an application and you're trying to figure out what do I do if I'm trying to find the last diastolic blood pressure measurement, you have a lot of trouble. And as I mentioned, this problem really exists everywhere that you look. And so we take another example, this time from the laboratory test domain, and you look at a single test, an angiotensin enzyme measurement, and you look across multiple institutions at how they represent those things in their lab test catalog, you find exactly the same problem. And there are all these little subtleties in here, like some of these names say that it's for a test that's quantitative. Well, what about the other ones? Does that mean it's qualitative or is it quantitative? Or which specimen is it measured on? Some of them say, some of them don't. It's tricky. Even in areas that you think are completely safe, like units of measure, like everybody should know how to represent a units of measure, you find this same kind of variation in many places. This is an example from a shared clinical repository of a single test, a platelet count test, and all the different string variations of how a particular unit of measure is represented. And the point of this little tour is just to introduce you to the idea that the representation of clinical meaning can't just rely on end users to create codes in their systems. We also have to apply this standardization and the use of common terminologies in order to overcome this problem, because what we see is that we want to be able to have our applications and our systems distinguish things that have a similar name but really different meaning. So we want to be able to distinguish the meerkats from the meerkat, because there are big implications if your application gets these things wrong. So terminology standards are the approach that can help us get closer to making sense of this messiness of health data. There are lots of different ways you could think about or categorize different kinds of health data standards. For today, I just sort of lump them into two main buckets. One are the kinds of standards that help describe the syntax or the format and the structure in which information is represented. And there are a few different paradigms. Of course, we're going to talk today about FHIR and its sort of API first model for that. But in addition to those kind of standards, we also have to think about and employ semantic standards, otherwise known as standard terminologies or vocabularies and coding systems, in order to really understand our health data. And across the broad domains that health covers, there's really no one standard that covers it all. And so in different domains, you'll find the use of different kinds of terminology standards. So if we're thinking about tests and observations and documents, you think about LOINC, but for medications, you might use RX norm. For diagnoses, you probably need to use ICD in some fashion, units of measure, UCOM, et cetera, et cetera. So different kinds of standards for those different domains, but the solution that they're providing is the same across them. So when we think about how this fits together, I like to say that FHIR and these terminology standards go together like chips and salsa, because FHIR is like the chip, like the real crunchy chip. That's the perfect delivery vehicle for feeding the salsa, the clinical meaning, the tasty goodness that the terminology standards can help represent. So to see how this works, I'm going to use an example of an example patient. So Esperanza Cordova. Today, Miss Cordova is not feeling well. She has fever, body aches, etc., coughing, congestions, not good. So she makes an appointment with her primary care provider, who's Aline Anderson. If we go to the FHIR specification and think about, well, how does that person, Ms. Cordova, get represented in that structured way, we see the different data elements that define the patient resource in FHIR. And inside of that resource, some of those data elements are places where we're going to want to use standard terminology. I've highlighted here on the screen a couple of those key examples, and you'll notice that they fall into a few categories. Primarily, they're the ones that have the data type identified as either code or codable concept. So we'll talk about those in a second, but as examples, you might think about the gender data attribute or the preferred communication language designation as being something that a standard terminology would be extraordinarily useful for. So when you're looking at any particular FHIR resource and you see that listing of data elements, in order to understand which ones are places where you're going to use standard terminology or coded terminology, you'll look for primarily one of these three data types: code, coding, or codable concept. Now, code is the simplest one. It's not used all that often, and when it's used, it's primarily for sort of status kinds of attributes, basically places where there's very, very high agreement on the set of codes that should be allowed at that element, typically a pretty short list. And in that case, you only see in the data instance the code. This system, or the place that defines that enumeration of codes, is implied by the element definition. So we'll see an example of this in a second. But again, this is typically short lists in places where there's high agreement on what that exact list of code should be for that element. The coding data type is one that is sort of the typical, the archetype representation for a concept from a terminology that has the classic triplet, which would be the code, the unique identifier, the display name, number two, and the system, a way to represent what coding system, what terminology did this thing come from. In addition, there are two other elements that you might find: version and user selected, which indicates whether that coding was something that a user directly chose in the application. But this particular data type, coding, with its representation, is not often used on its own, because in much of healthcare, where you want to see one code, you often want to see more than one. And so the more typical thing that you'll find, and you saw it in the patient resource we just looked at, is codable concept, which carries one or more concepts from a terminology using the coding pattern. So it basically takes that coding data type and nests it inside, but then adds one extra field, which is the ability to carry free text alongside it. So that is the codable concept data type, is the pattern that you'll see most often in FHIR. So how does this look if we go back to our patient, Miss Cordova, and we say, well, she is a married female who prefers to communicate in Spanish. And if we look at the way that FHIR would represent her patient resource, or could represent it, Can you find the code and codable concept elements? Now, if you're in the back, probably not, but if you're up front, maybe. So I'll highlight them here. You see things like gender in the code for female, but when we get to something like language, you see that pattern where there's a triplet of the code, ES, the display name, Spanish, and the coding system, the IETF standard, where that code is defined, as well as a text element, a free text element, just saying Spanish. So this is an example of how some particular data elements make use of common standard terminology. We go over to think about our patient who just had this appointment with their primary care physician, and we look at the encounter resource, which is the resource that carries the information about the interaction between a patient and other providers where services are delivered. You'll see other examples of where these data elements make sense. And so across these patterns, you see like status as a code we just talked about. We see an example, here's an example of coding, but a lot of different codable concepts for the type, for the service type, the reason code for the encounter, and so forth. And so in the context of Ms. Cordova, who's seeing her primary care physician for an ambulatory visit about her symptoms, we see reflected in the data then something like a code for ambulatory, which is defined by an HL7 coding system. We see the type of encounter being identified by a SNOMED code, an encounter for symptoms. And we see a coding that helps distinguish a particular participant, an individual, in this case, the primary care provider, in the context of the encounter. And that classification is using the HL7 participant type code system called primary performer. The code then is what carries the meaning that helps the computers understand what these different data elements represent.
Excuse me.
For our patient, because of the symptoms that she's having, let's look at one other example. So probably she will have some kind of SARS-CoV-2 test given her current state. And here we're saying that she's going to have a NAT test. And so that test result would be represented in FHIR using the observation resource. And if we take a look at inside of that observation resource, which kinds of data elements would we find codable concepts, we see quite a number of them. So number one, we see that the category of test is identified as being a laboratory test using a coding system from HL7 that helps separate out lab tests from vital signs and other kinds of information that a observation might carry. And the actual code for the test itself is represented by a LOINC code, which is specific to the fact that this is a SARS-CoV-2 test looking at RNA that is done by NAT. And the result value, the actual result for this test here, is indicated by a SNOMED code that indicates detected, which is bad news for Ms. Cordova, but helpful in illustrating how we can have coded representations both for what kind of test it is, as well as the result value that might appear for that particular test, if the test is a qualitative kind of result as opposed to a numeric. Okay, so that I hope gives you a flavor of how in FHIR different structures can be tied to terminology elements. But let's dive a little bit deeper. And so the FHIR specification actually provides an API for enabling terminology capabilities that were much, much harder to do before FHIR existed. And this is actually, in my view, sort of one of the unsung innovations of FHIR, is providing a common way to interact with terminology elements for computers. And so in the FHIR specification, the terminology module includes the primary sort of terminology sort of structures and operations. We're going to talk about sort of the big three, the CodeSystem resource, the ValueSet resource, and the ConceptMap resource, and some of the key operations that can be used alongside of those operations. So the CodeSystem resource is the structure that helps define the existence and the key metadata, and optionally even the content that is part of a coding system or terminology. A value set is a resource that allows you to define a structure for gathering one or more codes from different code systems. So you might think of this as a way to do a subset that would say, I just want to have a list of the SARS-CoV-2 LOINC codes and not all of the laboratory tests that are represented in that terminology, for example. And thirdly, the concept map is the structure that lets you define a set of relationships between concepts in one value set to concepts in another value set. And those don't have to be from the same terminology, though they could be, but they're often used in the case of defining mappings between different terminologies. So we're going to take a look at each one of these sort of step by step, but I wanted to show visually how they sort of relate together. So there's kind of two paths here, but you can think of code systems as the resources that define the terminology, the universe of codes or concepts that are represented by this collection. And then the value set is the technique that lets you select from or draw from concepts defined in that code system for a particular purpose or to narrow to a particular data element usage. And then a concept map is a thing that you can use to link concepts between different value sets if you want to assert relationships of some kinds between those two concepts. So in general, when I say terminology, when I say code system, these are the things that define symbols or identifiers for concepts. In some cases, they might actually be defining the expressions that are allowed as opposed to enumerating codes. But their job is to sort of circumscribe this universe. In FHIR, the code system resource is the thing that puts that code system into a uniform structure, and it organizes the metadata and provides some structured ways to interact with that coding system. So here on the screen, I'm using the example of HL7's marital status code system, which is what we, if you were looking real close, you could have seen in Ms. Cordova's example. And so up at the top, there's some sort of key metadata, and then down sort of at the bottom part of the screen, it's actually enumerating the codes and their display names that are represented. Now, this particular code system only has a handful of codes in it, and so this is a very convenient structure for representing it, and a computable one at that. But if we look at a slightly more complicated example of how the LOINC terminology could be represented as a FHIR code system, you see at the top here, there's these core metadata elements, and that's useful, the name of it, who publishes it, copyright information, et cetera. But you also see a small example of custom properties that have been defined for LOINC as a terminology itself. Now, this may vary from terminology to terminology. In LOINC's case, each term in the vocabulary is comprised of is made up of a structured name that has a few different parts. And so we can use the properties, these custom LOINC-specific properties in FHIR to describe definitively what those things are, and then draw the linkages between a LOINC term and those constituent parts, as well as do things like define the concept status, whether it's active or retired, say what version it first appeared in, et cetera, et cetera. And so this mechanism for representing properties is extraordinarily powerful, and we'll see this in a future slide for what we can do with that. So the key operations that FHIR defines for working with or interacting with code system resources are these: lookup, validate code, and subsumes. So lookup lets you pass to the terminology server a concept and get back information about it from that code system, including its definition, its status, any of those properties that have been defined, and so forth. The validate code operation lets you check to see if the code is part of that code system. So sort of on the fly, you can verify that this code is a real SNOMED code or a real LOINC code. Thirdly, there's an operation called subsumes, which helps you check the subsumption relationship between two codings, given what the system knows about that terminology. For example, you can say, hey, is code A subsumed by, or is a relationship to code B, and the server can tell you what it knows. So here's an example of how, using the FHIR API system, you can get information about your favorite LOINC term. So here we're using the lookup operation. You see that $ lookup, and then we're passing as parameters the system of LOINC and the unique code that we're looking to get information about. And if the server knows about LOINC, then what it returns back to you are all those different properties for that LOINC code. in a structured way. And you can see from the preview scrolling on this page that for any given LOINC term, for example, there are a whole bunch of different properties that you can retrieve and make use of.
Excuse me.
Similarly, if you wanted to validate
Yeah.
the code that you received in your system is a real LOINC term or a real term in any coding system, you can use the validate code operation. Here we would pass the same sort of parameters, the URL that identifies the coding system, as well as the code that we're looking for. And so here we're going to say, hey, is 1234-5 a LOINC term? And the server says, nope, sorry, it's not. And for you insiders who know already about LOINC, you shouldn't be in this room. No, just kidding. This is an intro session. No, but we have experts of all kinds here as well, which is great. But you might recognize that LOINC uses a mod 10 check digit style, and so that code isn't a valid entry in the terminology. But if we pass one that is, the server can then tell us that yes, this is actually a real LOINC term, and it returns back true, and it shows you what the display name is. So this is very useful in terms of scripting out a check on data that you might receive from another party, whether there is in fact sort of bad data or typos or so forth. All right, so that's CodeSystem. Let's talk about ValueSet, which is another key structure in FHIR. So the ValueSet resource also includes a core set of data elements that represent metadata about these value sets. The name, the version, status, information about the publisher, and so forth. But the real fun comes in the compose element, or the sort of structure underneath compose, which is how you define this set of codes, this subset. And there are really sort of three main features in the value set definition that you can use to select codes from different code systems. The first way is to use the structure here for concept, where you can kind of just list out the codes that you want to include in this set, kind of enumerate them one by one. That can be handy. The second way that you can compose the definition is to use filters, which interact with those properties that are defined to provide kind of a query that selects the concepts from the coding system on a dynamic basis. This is especially handy over time when those coding systems may evolve and publish new versions, and this definition can still execute on those filters and retrieve new codes that may have been added that meet your criteria. And then the third technique you can use to build a value set is by pointing to other value sets. So you can compose by sort of pulling in other value sets that have been defined elsewhere and combine that with those other two features as well. And then lastly, there are similar techniques for excluding terms from your collection. If you say, I want to have these four, but not those that are inactive, for example, or have another property that I don't want. So let's look at a couple of examples of how this looks. So here's a value set that is meant to define the set of COVID-19 lab tests. And so up at the top, you'll see the same kind of metadata information about the publisher, et cetera. And then the sort of middle and bottom section is the structure that defines or uses the compose. And here what we're doing is we're using this sort of long list of enumeration to include the various concepts that are in this set. So one by one, we sort of list out the terms from the vocabulary, in this case, LOINC, that we want to include. Here's an example of a COVID-19 diagnosis list. And this particular case is using the technique of referencing other value sets. So here, there's metadata at the top saying, MITRE created this set and named it. And what we're doing is we're saying, I want to include all the concepts that are defined in these other three value sets. One is, well, two are related to ICD-10 diagnosis codes for COVID-19, and the other drawing from SNOMED. And so that's a handy way if you want to sort of build up structures over time. You can sort of build the lower levels and then assemble them in blocks. And then last, I'll show you the technique of using the filters, or sort of the dynamic queries, to construct the value set. So here, let's take a look at an O2 saturation test value set, where we want to select codes that are oxygen saturation measurements. And we can use a couple of LOINC specific properties to query for those relevant terms. So in this case, what we say is we want terms whose component, which in LOINC speak is like the analyte or the thing that you're measuring, to have oxygen saturation in it. And we want those terms that have a kind of property of mass fraction, so that we pull just those sort of percent measurement terms. But we don't want to have any panels. So we don't want lab battery things that may happen to have oxygen saturation in the name. So we use the exclude technique to sort of pull those out. And so that's super handy because it can be more flexible over time. But you might be wondering, okay, if I use definitions like that, how do I actually get the list of codes, from that, right? So I just kind of sketched out those criteria, but how do I actually get that? So that's where the operations come into play. So the operations for ValueSet that are of interest are expand and validate code. Expand is the operation that executes the definition of the ValueSet and returns the collection of codes that meet that definition. So that is the technique for getting back the actual list of codes that you want. And when you use the expand operation, you can pass in two key parameters. One is filter, which is to say I only want to include concepts whose display name matches the string, or date, and you can say generate the expansion of this value set based on a particular date. So that can be super handy. Validate code is an operation that works pretty much the same way as it does with the CodeSystem that we saw earlier, which basically just checks to say, hey, is this code that I'm asking about in the value set? And the server will return yes or no, it is. So let's see how this works. So here, if we go back to that example of the COVID-19 diagnosis value set, which had concepts drawn from ICD-10 as well as from SNOMED, if we tell the server, go to this value set and use the expand operation, $expand, you get back a value set resource with this bottom block of expansion enumerating out those codes. So here we've got a couple of ICD codes and the one from SNOMED CT. So that's pretty cool. Here's an example of how we can use the expand operation as well as the filter parameter. So if we go to the value set of SARS-CoV-2 lab tests, and we say expand that value set, but filter those to only the ones that have NAA for nucleic acid amplification in the name, then the server filters out only those codes that are inside that broader value set, which can be handy if this is something where you're populating a user interface, where you might have search sort of tied into that interface. All right, so the last resource that we're going to talk about from the terminology module is ConceptMap. And ConceptMap similarly has a whole block of data elements that represent metadata about the mapping. So we have titles and statuses and publisher information and jurisdictional information, etc. And then the meat of the ConceptMap is structured underneath this group element. And the group element is where you enumerate one or more groups of mappings. And whoops, I thought I had some blocked. But basically, you can align concepts from these different value sets and indicate the kind of relationship or equivalence between them to say this one is equal to or equivalent to this other concept. This one is narrower than this other one, etc. And so once you have that, then this structure can be super powerful for doing translations between codes, which is what the ConceptMap operation called translate helps you do. So in this case, if you're a client, you pass to the server a concept and you say, hey, can you translate this code into another one based on the information that you have? Now, there's a little bit of caution that we're not going to get super deep into the details of how ConceptMap works for one main reason, and that is there's a lot of structural changes to how the ConceptMap resource will look in the current FHIR version with what's coming in FHIR R5. And in fact, actually, R5 is going to have a new resource called ConceptMap 2, which has these new features while kind of keeping the existing one, at least for now. And some of the details about what has changed in that include clarifying various aspects of defining the source and the target, and these features of saying, well, this mapping depends on certain other attributes, as well as how the translate operation works. So if you are fascinated by how ConceptMap worked and would like to understand for the future what's happening in R5, please come tomorrow to Rob Housem's talk, which is going to get into this in detail, illustrating the updates that are coming in R5. But for now, we're just going to sort of illustrate how they work and where you might find some of them, because ConceptMap is not quite as common as ValueSet, for example. But the standard terminologies are one place that publish these. So in LOINC and in SNOMED, as part of their core distribution, those terminologies often include mappings from the concepts in their terminology to other concepts in different terminologies. And both publish these and make these available as FHIR ConceptMap resources. So for example, you can go from LOINC terms to a variety of other codes like RxNorm I meant to say RadLex playbook terms for radiology procedures, or some of the IEEE device codes. And the parts, the LOINC parts, the little pieces that make up those terms have been mapped to a variety of other terminologies as well, including RxNorm or NCBI, et cetera. And SNOMED makes available mappings both from SNOMED CT terms to read codes, as well as ICD-0 and ICD-10 as well. So what this enables is when a terminology author does the work of creating one of these ConceptMap resources, we can then benefit on the client side. So here's an example of how the client can ask the server for, do you have any translations for the SNOMED CT term 840-539-006, which is disease caused by SARS-CoV-2, into an ICD-10 code. And so that big long sort of block up there basically says, can you do that for me? And it's identifying the SNOMED code, where it comes from, and the target that you're looking for, in this case, ICD-10. And the server can reply back simply, yes. And along with, the target mapping that it has based on the information that it might have got from the SNOMED publication. So that's super handy. Likewise, we can say, hey, do you have any translations for the LOINC part, which is the SARS-CoV-2 M gene? So certain laboratory tests might be targeting specifically the M gene of that. Do you have any translations for that element? And the server can say, yes, I do, based on the mapping that Registry publishes. I've got a mapping to the NCBI gene ID for the SARS-CoV-2 M gene, which is pretty cool, because then you could jump from that ID to other knowledge information that might be available about those codes. For example, data sets or the actual sequence for the M gene and so forth and so on. So the translation operation is what helps you sort of navigate across different terminologies and really grab some of the key knowledge that's been done by the authors of those terminologies. So as we conclude today, I want to leave you with sort of two main lessons. In the first part, we sort of talked about, and I'm borrowing this phrase from a great paper that's focused on the machine learning community, but it sort of says, everybody really likes to do the fun stuff, the API stuff, but we kind of forget sometimes about the underlying data and its representation and the way that those codings might affect what I could actually do with it. And so I wanted to illustrate a little bit about how that translation from local representation to standard concepts is super important, and we can do cool stuff with it. And then now you also have a taste for how the same interactions that you might be familiar with FHIR, of defining resources and structures as well as operations, can really unlock a whole world of terminology knowledge that can provide fuel for innovation and improvement. So with that, we will wrap up, and I think we have time for a few questions.
Thank you, Dan. You're right on time.
Yeah,
if
I
you have a question, I'll come up to you, but if you allow me, I'll start with the question from the online attendees.
Absolutely.
Which is a question here. You showed $lookup system and $validate code URL are both acceptable pathways.
Yeah, so the answer is go back to the spec, and so we'll see. So yes, typically the way what you want to do is look at the definition for the operation and what parameters are accepted in that definition and what the output are. And so that's kind of a one level deep in the specification. So I don't know if it will work, but I can try to Alt Tab. And so if we look at, say, ValueSet validate code, then, whoops, I want to Control plus. I'm not zooming in. There we go. We can look at the in parameters. So I jumped kind of quickly, but I went to operation validate code on ValueSet, and we look at the in parameters, and here you see that one of those parameters is URL. So that's expecting to say URL for the ValueSet one. Yep.
Yeah, sorry.
Titus FHIR from the Regenschiff Institute. Great talk, Dan, as usual. Tell us a little bit about how does this work in the context of terminologies, on average, being living and breathing things. You know, terminologies evolves, terms get deprecated, terms get added. So how stable is this in light of that?
Thank you. That's a great question. One of the things, I'll start by saying one of the things that's nice about the FHIR representation of these various different terminologies is that it provides a uniform structure that the different terminologies can be interacted with similarly, right? So rather than having sort of different techniques for representing deprecated or retired codes for LOINC, SNOMED, ARCS norm, ICD, there's a more uniform structure for doing that. So in some sense, the FHIR representation simplifies interacting with those very dynamic things. Secondarily, though, it's a really important point that these things do live and breathe, and most have a somewhat regular update cycle. And so this is not work that's ever done, per se, which is why the representation and persistence of versioning, which we didn't get into a lot, is actually a key component for understanding how those things can evolve over time. So I mentioned that many of those different structures have version elements. What I didn't mention was how you can use that sort of stacking over time to both rewind and go back to what existed before, as well as find whatever is current, which also helps with that. But your point also is key to think about the fact that there's a lot of upkeep that's required in maintaining data and understanding sort of the information that you're receiving. And that happens sort of across all of these different domains that each kind of have their own life cycle. Some spin faster than others, but that's essential for valid interpretation and upkeep of health data. Yeah, thanks.
Thank you, Dan. Maybe another question here from an online attendee. I encountered situations where some data sources send the same coding systems differently. For example, some may send http snowmed.org while legacy CCDA sources send URN, OID to and so. Some legacy systems send SNOMED CT. What is FHIR recommendation to know these are the same system?
Good. So there is a place, and if I'm savvy enough to find it, there is, I think there's a page called Using Codes with FHIR that essentially lists the known canonical URLs for various coding systems. And that is the agreement within the FHIR community on the way to identify those different systems. So typically in that system field, it should be the canonical URI. And then from the metadata that's in that code system resource, if you have the URL correctly, that URI, you could find some of those other alternative identifiers because they're listed in that code system resource. But in the instances of, say, 1, 2, 3, 4, 5, display name, system, that system should really be the same. And there's a page in the spec, and it's called Using Codes with FHIR, and maybe somebody can find it more quickly than I can, but it's there.
Dan,
Thanks.
here's another question from the audience.
Thank you. Actually, a couple of questions. When we do the lookup for specific codes, I'm noticing that the lookup operation is not using the standard search parameters that's being used in FHIR, using like the code pipe, the system.
Right.
Right? Is there any reason for do that, just to be for consistency? And the second thing is, so the implementation, we looked at different coding system. What are the best practices? Do we need to reference these code systems from specific FHIR servers on the internet, or do we need to deploy them in as well and get license for it in the current organizations that we're in? Because that's multiple things, multiple licenses, things like that.
Oh, good questions. So I actually don't know the answer to your first question, why or how they're defined, but there might be somebody here that does. So I'll see if anybody else knows the answer, why if they're different from the main search parameters. I don't know. The answer to your second question, I can take a stab at and say that there are lots of factors that would go into your institution's decision about how to manage that. So certainly terminology management is kind of a big deal. And so how much you want to invest in it depends a little bit on how much you want to do with it. In some sense, there's value in federation, where you try to rely on, say, authoritative sources to kind of keep up the hard work of it, and then you can sort of rely on servers or services that do that and keep up to date with the latest SNOMED versions and LOINC versions, and you can then just interact with that rather than having to natively host that. But of course, there are probably performance reasons why you may or may not want to do that. So people make different choices about whether they want to deploy those resources internally. There's also a choice about whether you want to separate out the terminology specific functions from your other main FHIR based capabilities. And there are certain products that sort of specialize in advanced terminology stuff that kind of stand alone, which can be also, useful, but there are cases where you may want to do that internally as well. But for sure, in each of those cases, you have to think through what the licensing implications are of the terminologies that you're using. And typically, some in the FHIR community are openly available and freely available, and there's really no restrictions per se. Others are much more restrictive. And sometimes your restriction as a receiver of data coded with this information is different than if you're redistributing or providing services on top of that make use of those codes. And some of the different licenses, like here in the US, the CPT license from AMA is an example of one that you'll want to pay close attention to your usage and how that relates to the license. Whereas others, such as the HL7 coding systems that are kind of built into FHIR, essentially have no restrictions on their use.
Thank you, Dan. Here's another one. Can you specify a version of a code system to check against for validation, or find out which versions support a specific code?
Yes. So if we go to the code system and, I meant to go to operations, validate code, you'll notice that one of the input parameters is the version. And so this would be on the input side, you can say, check if this SNOMED code is in this particular version. I'm specifying what version I want the server to check against. And so that's how you would do it, is you would use an input parameter of version, and then the server can respond that way. Yep.
One from the audience. Oh, I'm coming over. One moment, please. Ken.
Hi. Often if you're building a FHIR repository from multiple sources, you're going to be getting your data in with different kinds of terminology. What do you recommend about best practices around normalizing the data on the way in so it's searchable?
Yeah, so that's a fantastic question. So one of the features of FHIR is that you can build up concept maps. So you can build up mapping, say, between the whole collection of codes that you receive on the input side and preferred or target, terminologies. So in general, a sort of starting principle is don't throw away stuff that you got. Right. So there might be sort of an inclination on the ingestion side to have some lookup process that replaces them in line and then passes it on down the road. Invariably, you'll find times when you wish that you had the original thing. So keep it all together and annotate over time, or annotate towards a preferred or canonical representation is the sort of starting point principle. The exact technique for how you do that, I'll say, ConceptMap resource can let you do it sort of in FHIR. You could also do that natively if your internal store is something like a relational database with tables, and then use the API to only surface sort of those canonical, sort of mappings or terminologies. So you have some different architectural considerations, but there's a lot of complexity inside of your question in terms of governance and what the agreement in your community is about the sort of preferred terminologies for certain domains, as well as whether you have enough information to convert to those canonical terminologies based on what you're receiving from the sources. So a lot of complexity there. I think the good thing is that we now do have more computable ways to interact with different coding systems, and that can be helpful for the very real problem that you just described.
Okay, well, thank you, Dan Vreeman. Thank you, everyone, for joining the session, and see you in the next session.
All right, thank you.